Alright guys, let's jump right in. Tonight we're tackling a topic that's both incredibly powerful and surprisingly accessible: Monte Carlo simulations. Now, you might be thinking, Monte Carlo sounds fancy. What's that all about? Well, think of it as a supercharged way to predict the future. It's a method that uses random sampling to estimate the probabilities of complex events. Imagine trying to predict something crazily unpredictable, like the weather. It's a chaotic maelstrom of variables: temperature, pressure, humidity, a million things. Predicting it exactly is impossible, right? That's where Monte Carlo shines. Instead of trying to figure out every single variable, Monte Carlo uses tons of random samples from the input data to estimate the outcome of the system according to the model. Think of it like throwing darts at a dartboard, trying to hit the bullseye. The more darts you throw, the better your chance of hitting close to the center. The more you simulate, the closer to the real value and more accurate your estimation. This method has been used for centuries across many fields, from understanding financial models to the very heart of physics. So, by simulating lots and lots of random possibilities, it builds a probabilistic view of the future, helping us understand the likely range of outcomes and the uncertainties involved. And that's super valuable, especially when dealing with those systems and events that are essentially impossible to calculate deterministically. Now, Monte Carlo simulations have been around for a while. However, they can be painfully slow, especially when dealing with really complex scenarios. Enter artificial intelligence. AI is taking Monte Carlo to a whole new level, making them faster, more precise, and capable of handling challenges that were previously unthinkable. Think about it. AI can learn patterns, find solutions, and generate a vast number of options more quickly and effectively than any single human-made model. Using deep learning, for example, we can create AI models that analyze these random simulations with much more nuance and sophistication while doing it at speeds that would only be dreamed of before. The result is a massive efficiency gain. We're not just talking marginal improvements, we're now talking about a jump to new capabilities. You're talking about the ability to simulate those incredibly complex problems in minutes, which before would have taken decades on those older systems. This has major repercussions across different fields. One of the most exciting applications of AI-enhanced Monte Carlo simulations is in finance. Predicting stock prices is notoriously tough. A million things can affect a single stock price with high speed and nonlinear reactions. These models use Monte Carlo simulations to run simulations of millions of different outcomes, to evaluate the probability of a particular outcome and predict the evolution of many different variables affecting the market. But doing that manually would be an epic, impossible task. However, with AI, we can make it a manageable one. By combining AI with the power of Monte Carlo simulations, it is possible to do sophisticated risk management, predict the impacts of future market volatility with much higher degrees of accuracy and efficiency, to create more intelligent trading strategies, which can lead to better returns and optimized portfolio decisions. We can go further by leveraging quantum computing, which again is a game changer and could revolutionize financial forecasting. The sheer number of possible outcomes and variables makes it ideally suited to the capabilities offered by quantum computers of the future, improving accuracy and speed in the same time. Early adopters will likely experience enormous gains, which reminds me of a funny story. Let's shift gears and look at medical physics. Monte Carlo simulations are the gold standard for calculating dose distributions in radiation therapy, especially for those complex scenarios such as proton and ion therapy. Because of this, it is very widely used for modeling beams, computing doses, and identifying optimal treatment settings. But these simulations are incredibly demanding, needing massive computing power and time to generate precise results. That's where the synergy of AI becomes especially powerful. AI can accelerate the MC process, improve the dose map precision, help with more intelligent event selection, and even model complex detector responses directly. That means faster treatment planning, more accurate dosage calculations, and better treatment outcomes for patients. These simulations can deal with incredibly complex geometries, such as those observed in treatment heads, and all this results in safer and more effective cancer treatments. This is not mere prediction, but also helps to improve design of the radiation equipment, a massive leap forward in medicine. Now, let's move to another exciting field: materials science. Monte Carlo is a critical tool for predicting the properties of new materials, from molecules to crystalline structures. Scientists frequently use Monte Carlo to understand how molecules organize into new phases or self-assemble, for instance, in those systems for which the phase transition time is too long for other methods such as molecular dynamics to easily observe. But simulating these complex systems require a large number of calculations for higher accuracy. AI-enhanced Monte Carlo can accelerate the simulations enormously, helping to design new materials, improve quality of those materials, and optimize their properties. It can be used to design new molecules, predict their properties, search optimal structures, and even predict phases behavior and phase transitions. This is particularly valuable today as researchers begin to explore new material domains, from creating new drugs that more efficiently target cancer cells to designing sustainable materials to support the green energy revolution. While the potential of AI-enhanced Monte Carlo is immense, there are still challenges to overcome. One is the quality of the data available to train the AI, as it will directly impact prediction capability. The AI model must also capture the underlying physics to produce realistic and dependable predictions. We also need to assess the uncertainty associated with AI-generated predictions and have reliable ways of showing whether these results are reflecting real physical phenomena or are simply learning from noise in the data. This requires robust validation strategies and also open, high-quality datasets. We certainly need more collaboration between fields to overcome these challenges. Developing explainable AI models is critical in this context. This means that to fully trust and exploit AI in Monte Carlo, we need better understanding of what the algorithms are doing and why they make which predictions. Only then can we confidently integrate these new AI capabilities in daily practice. In terms of hardware, further acceleration can come from better integration with next-generation computing hardware. GPUs and quantum computers offer tremendous possibilities here. The future promises a seamless integration of AI and Monte Carlo simulation methods, a fusion that will create new avenues for discovery, innovation, and problem-solving. We'll also see more collaboration between developers, scientists, and industry experts, and there will be more efforts to create open data initiatives. It all truly sounds exciting. This technology is about to go large. So there you have it, folks. We've journeyed through the fascinating world of Monte Carlo simulations and explored the transformative power of AI in making a remarkable impact on this crucial tech. From predicting market trends to designing life-saving medical treatments and the development of revolutionary materials, the potential applications are just mind-blowing. I hope I've shown you tonight just how far this area is evolving with the exciting integration of AI and Monte Carlo. We are already seeing breakthroughs in several key scientific and technological applications, but we are only just beginning to explore this potential. Don't wait, start experimenting now and embrace the future. You might just unlock the next major step in your field and who knows, maybe even win that lottery. Remember to subscribe to All About AI Tech for more incredible deep dives into the world of artificial intelligence and beyond. And don't forget to like and leave a comment below. Let me know what you thought and what you'd like to see next. Thanks for watching, and keep innovating. We seriously appreciate your support.